Oh, I like.
Recording in progress.
Cool.
I think I probably said that I'll do something on
With that
addition of
Anybody
angle,
else
addition of
wanted to
angle.
maybe add something? Do you have anything to add to whatever we have done?
Not right now. I'm just I was saying that the intertwiner, this word is very representation theoretic, and which is kind of true, but I'm still like writing up the entire thing. So I'll let you know when.
So did, okay.
Well, thank you. Yeah.
Anybody else wanted to?
Not really. We've been kind of working with this operator, which I showed that commutation relation.
Okay,
Oh yeah, that's what I was planning to do, but not in this way. I asked you to do something, but that's why I thought it might be useful for Jackson
Okay.
also.
okay.
So maybe
So it's still muggy in here. I can't breathe. I tried to tinker with that and it says it's set to like 60, which obviously isn't true. It's almost 80 in here. It's like 76 in here right now.
Oh boy, I can feel, yeah. Okay.
Got the
Shajesh,
fix. That's what started.
the number one.
No, like it's
For the seventh time you
or in
7.
It's so muggy in here that when I opened this, the lens fogged automatically.
Oh, yeah.
Like in my apartment at like 65.
So let's make it shorter than 3 hours.
Shorter than 3 hours would be nice. Wife picks on at 6.
do I use this?
This one. The God Chalk.
Yes. So if you guys recall, sometime back I said angular momentum can be written as 2 harmonic oscillators, and almost immediately next time Nurek made a diagram out of it, and there were ways to see whatever we know about angular momentum in there, and it also very briefly we talked about what about other directions, what are the operators that go in other directions, and I was reading about what I could give as a project for Jackson, and then I thought you can build such a thing, and it exists. I think it has nothing to do. It is probably SO21. You always say SO3, but why not SO21? So I think SO21 is also there in that.
Something, yeah.
I think SO21 is also there in that same construction. That's my ground. So I will just try to build the. I'm not prepared in the sense that I have a complete lecture. I can build something here if you guys work with me in a sense. So hopefully it will be useful. Is that okay? You reckon?
It's a combinatorial thing, you know. Okay, I'll show you maybe later.
Yeah.
Something, yeah.
Well, go ahead and do it, and then we'll say, okay, this is just Groucho polynomial.
Yeah, right, right.
Oh, you don't put so much effort. This is all already known.
Everything just
Yeah,
the
of
same
course.
thing related.
Yeah. That's almost my life. Everything I do after 5 years of work. Oh yeah, that's there in 200-year-old paper. Yeah. Okay. So I think recall. So these are harmonic oscillators. 2 harmonic oscillators we want. So remind oscillator. That would be 2 of them. So we said. Like, so we say there are 2 operators, right? A comma A dagger is equal to 1, and if we have an operator NA, which is A dagger A, then its eigenvalues come out to be. So prime means eigenvalues, so it is 0, 1, 2, and so you want to build 2 of them, so it is A and A dagger, and we said the properties of this are that A dagger A, which is the operator NA, acting on a state gives you so that's a basis set suitable basis set.
You have n prime inside.
Yeah, because these are the labels I'm using for
for the vector representing that eigenvalue.
Correct. Yeah.
Okay.
So that's again, that's a Dirac's notation saying that.
Oh,
I
yeah,
think
it
that's
just
okay.
like
I think
enough,
it's
like
okay.
3 or something.
Yeah.
Okay.
This
So
looks like funny, right? Like a vector with 3. It's
vector
okay
with-
because it's a nickname. It's the nickname of the vector.
yeah, this is index. I usually
Yeah.
say
No, that's fine,
index.
that's fine.
That label of it. Yeah, you said nickname, label for it,
Yes, exactly.
label for the state. So this is the label for this state.
The standard thing, right?
Yes, so this is a harmonic oscillator, and we want to double it. We want to make this 2 harmonic oscillators. So there is a D also, exactly the same idea. So another harmonic oscillator, say, and where you say A goes to B. So everything repeated. Then it also requires me to say that they are decoupled. So anything involving A and B commutational relation is 0. So they're decoupled harmonic oscillators. And Urek suggested the following diagram. So there was an A prime, then B prime, let's say. So let's see. And if you were, I think the idea is that if you take any diagonal element in here, that is a fixed J. So these are all J's. So in this direction is your J, but J is not yet here. We have angular momentum in mind there, but I'm going to build that in a minute. And this is NA, NB, and what else can I say? That's once you have this fixed J, in angular momentum, we also know that is a J plus, and that is a J minus. Once I fix my space, that means each of this is a subspace. All out of this, all the total angular momentum you can have. And if you fix yourself to that, then going up and down is got by J plus and J minus. But now we are saying that what about like at least the proposition is that what about this? So that goes to infinity, right? All the way. And but it also has a lower limit. Notice if I start from here, there's this lower limit also. Correct. So can we build something in that direction? And I'll call them K in general, K plus and K minus. And the question is, what are Ks? Right? So can we build something like that? So that's the idea. We go back to angular momentum itself, and I think Seth, I think you sort of said we go this way, that way.
What's the difference between K and J?
As of now, I have only said that K will be perpendicular. And I have not said anything about K's or for that matter J's either. I haven't built it, even though we have done something
So by
about
K you mean operator?
an
Yeah.
operator, yes.
Okay.
It like traverses
Okay, that's
J's
fine.
and the J traverses M's,
Okay.
which is kind of backwards thinking. That's kind of funny.
Yeah, let's see. So one way to think of is that okay, suppose it is or maybe here, this is A dagger, right? And that's A in terms of harmonic oscillator that we have. Here we have B dagger, and that's B. Correct.
Yeah.
Mhm.
And if I want to think of J plus, so let's say define, like that. So this is the definition. So define my J plus as I'll use H bars, and this is going diagonal this way. J plus is in this direction, right? Yeah, maybe right here itself. So this is J plus. And that's J minus. And I want K plus here. Yeah, so now this should be clear, right? Yeah. So this is my
Like-
construction. Yeah, that's the answer to what is K plus K minus. Here, I think I wrote it randomly in the context of A dagger.
Right,
A
right,
dagger.
right, that's
Okay.
So would you say it's like H bar, A dagger, B?
Correct, exactly. So J plus will be so definition will be A dagger B. And J minus would be H dagger. I have to go this way, right? So A B dagger. Right. And clearly, immediately you see that, oh, this is permission of each other. J plus dagger is J minus. This is all we need when we are doing harmonic oscillator, sorry, angular momentum, J's. But here we are going to do something as a case also. So I'm going to right away say what is K plus. This is H bar. So instead, you pointed this out yesterday immediately after we discussed this. So it's pretty much what you suggested. So yeah, you should have done it. Yeah, okay. So K plus A dagger and B dagger and K minus H bar A B. Right. So that's your construction. Next, yeah. So next, so now I construct few things. So these are the only definitions I use. Let's build a few things. I want to work with X, Y, Z, right? So let's say Jx, I say is by construction, right? J plus J minus over 2, right? Save space. So 2 and the same thing of let's leave the K plus K minus. Right? So Jy, I will say is K plus minus K minus over. And it's not obvious why I do that because I'm thinking inversely with respect to usually we construct J plus out of X and Y. So, but since we know angular momentum, this I is there immediately. And Jz, I will just call this whatever comes out of I over H bar of Jx and Jy. Now, once I have this, I should be able to build it in a sense. Kx, I would say now this will be same idea. K plus K minus over 2 Ky will be K plus minus over 1 over 2i. And Kz, I will leave it open. This is where I said I had not completed the calculation because it's yeah, I'm not very familiar here. I'm so familiar with it that I can fill in the spots. Here, I think I need a minus sign. So maybe I can tell you what I'm confused about is that I get a minus sign here, which maybe it's okay because it's SO21. So I get this piece here. I'm not very sure. But maybe I'll circle this and question mark. It sort of I'm not very sure about. And the goal here is now so based on this goal, let's say, right? Goal is what is the commutation relations between them? So what is Jx, Jy over 1 over I bar? So Jy in AZ, what is this equal to this equal to 1 over IH bar Z. So that's the first step. What this is, and once we have, we should be able to see that. So probably Jx square plus Jy square plus Jz square. Probably this commutes with everything. So any one of this, then it is an invariant operator. So probably this is 0. So that's one thing you want to check. So maybe this should be 0, but we are going to check that. And here do the same thing. 1 over IH bar. Jx, Jy by construction is going to be easy, right? So that's still. Okay, let's Ky, what this is maybe explicitly. Ky, so this is what I was saying, we can calculate this. Yes. And here I suspect, again, I haven't done this. Suspect is K square, Ky square minus KZ square.
Minus,
I think so.
that would be cool.
I think so. Okay. And this in some circles is called hyperbolic angular momentum. I like that word very much, but I mean, for many days I'm thinking about this. I just was using hyper, but then only today I realized that's nothing but SO2 one, right? So it's much more simpler to identify like that. But yeah, so that's what I meant by yeah, that's the goal. So now basically I can just do this each one and try to fill that in if you allow me, right? So that's sort of ends the story, at least as far as some step. Okay, so 1 by H bar Jx Jy. That's 1 over H bar. Jx was here. Oh, first we should calculate Jx and Jy separately, right? Maybe. Yeah, Jx is 1 by 2. So H bar over 2 J plus. So it is A dagger B plus AB dagger. So maybe I should write this down. It's not going to be. This is equal to H bar over 2 A dagger B plus AB dagger. H bar over 2I. This variable. So this is having H bar over 2, H bar over 2I, and is A dagger B plus B dagger. That's what it is. So that's equal to the minus sign minus H bar over 4, right? And 4 pieces.
But the first.
But
commutes
first
with
one
the
is 0, right?
yeah. And the second as well with the
This
second.
one is also 0. So yeah, it's so A dagger B minus A B dagger plus. Did I know? Did I? I capture that term.
Yeah.
So this is H bar for 4 and
Shortcuts.
I'll just do it. It's okay.
Mm.
So,
You can write disease.
then easier.
Simple, then you know it's.
Oh, I see. But you know it's none of them. Yeah.
That's what I'm. Disease. That's it. Let me know.
This is an easier way.
What about the minus sign? Are we just gonna lob that out front?
No. I wrote that as a mistake. You mean this, right?
Yeah.
I don't know.
Yeah. No, I forgot that.
Yeah.
It's better to check.
Yeah, you check it.
So this one, since A and B is commute, that doesn't contribute, and B and B dagger is 1.
Mhm.
B and B dagger is 1. So this whole thing is A dagger and A comes out, right? That fine. So A dagger A, right?
Yes.
Mhm.
And here
That's
A dagger A
Forget
is
just B dagger. out.
minus, so it is
So B dagger B.
B dagger.
And then that's A dagger.
So it's A dagger with a negative sign.
So,
plus-
yeah.
Plus A dagger, right? A dagger. And this one is A dagger is one,
So
but it's B
plus B dagger.
Yeah, we can switch this either way we want to. So usually this is like A dagger, A is the operator or N. So let's keep this and invert that way. H4, A dagger, A dagger, B. This one is A dagger, A plus one, right, using the commutation relation.
Mhm.
And this one is B dagger, B plus one. The ones cancel out here. And these are twice of that, so this is to the H bar over
Over
two
2
times A dagger A
minus
minus
B dagger B.
B. And if you recall that, like when we were doing this, this is H bar over. Oh, this is NA minus NB.
Yes.
And this was used.
Yeah. You're using prime mouse, right?
Now it is, these are.
Oh, no, these are operators.
These
That's
are
fine, that's fine,
operators,
that's
right,
fine.
Yeah, so. I think, but when we did it, yeah, we started with the primes and went back, so this was the whole thing, we did it in
Okay.
reverse there. But the main idea is I'm going to call this is now I'm, at this point, everything is being defined. So this is going to be defined as JZ. So I'll define this to be H bar over two. And you see the process here, so I want to do the same thing there, that's a simple idea. This is A dagger, A, B dagger. B. So erase this, right now we got this product. Yeah, so do the same thing now with J, JZ, JX, so we got this right now, JZ, this stuff, so now do this, and do the same thing here.
Yep, sufficient. Are we just going, are we gonna do the computations or are we gonna assume the results? We can, yeah.
In this case, we can assume because that is not questionable, here is what I'm worried, so maybe we can
Okay.
assume this and go there if it is boring.
Yeah,
right?
that's fine.
Right, so this comes out to be, I did check in the morning. This comes out JX and this comes out J, exactly the same steps, nothing fancy or nothing new comes up, no tricks are needed. I didn't do this yet, that's another thing. So let's do this now.
So JZ has the H bar in the denominator, while these guys have in the denominator.
No, H bar should be in the same place, that's dimensions, right? Did I write it wrong?
Yeah, no, I think you're okay. Yes, everything's okay.
Yeah, so H bar is, I keep it for dimensions, so.
Yeah,
I put it.
that's fine, that's fine.
Perfectly, okay, yeah. So. 1 over. AX. Oops. N over 2y. And AX and KY is. Or P dagger and F. Plus. So. Right.
Okay. Okay.
And we do sort of same thing, minus and a H bar in fourth. And it should be zero, right? Same operator committing should be zero, same operator commuter that should be
Right.
zero. So So we have minus. B dagger.
Okay, we twice the same thing, right?
And that's twice the same thing, correct? So yeah, so that's all okay far over here. The plus side, let's keep it. Yeah, twice the same thing. And that's now equal to over 2 A dagger, B dagger. Your B dagger B is minus. Correct. So this is A dagger A, a minus sign.
Oh, with the minus in the front, wouldn't that stay like in the next step?
This one?
Um,
Oh, here to here.
yes.
So I was saying,
No, because these two are same. If you change it from AB, you have to
Yeah.
commute
right.
it. So the
You purposely chosen to be negative to cancel out the sign.
okay, got it. Mhm. Got it.
He has chosen the first one as the main, yeah. It seems to be okay, right, or not? Yeah. Okay,
yeah, okay. Think so, okay. So here, what are they doing? Yeah. So A dagger A comes out, so this B dagger B is minus 1. So that's this. And the other one goes to 0. And here it is again minus h bar over 2. A dagger A is minus 1, that's a minus 1, so it's B dagger. But we like to write it as B dagger B, so switch this again. So it's a minus h bar over 2 A dagger A. So this is B dagger B plus 1. So yeah, so in a sense, this is overall minus sign h bar over 2 A dagger A plus B dagger B plus 1. And if you write it in terms of A and B plus 1. And yeah, so that's what it is.
and we didn't have this +1 in the other case, in the previous case, right?
Yeah, we didn't have the plus 1.
Okay.
But the 1 usually commutes with everything, right? So this is probably harmless. This is a negative sign is probably more.
Hmm.
Yeah, so what I was doing, at least in the morning, is that I didn't like this negative sign. So I said I'll define this as minus KZ. But what I propose is that let's say this is KZ.
So let's call it KZ, the whole thing.
Yeah.
Okay,
If,
yeah,
I don't know. I mean, we will see. That's
yeah,
fine,
all right, all right.
right? Or Seth, do you have some suggestions? Yeah.
Not particularly now.
It's sort of your suggestion. So
I really haven't thought it even close to this far.
yeah, this is kind of. Yeah. So okay, so let me say something now for thing Z, right? So yeah, let's say we just stick to this,
Yeah, that's okay.
right? A dagger A, what's that? B. And SO2 commutational relations has 2 negative signs here. Like, how is it different from here? Like 2 of them have negative signs that I checked just 10 minutes coming before coming here. So that's something we can keep in mind too. So I copied this here, so I can erase this now. Right. So okay. What we do K YKZ.
Mhm.
And there's a minus sign in here. So minus 1/5 bar, H bar over 2, and H bar over 2i. That takes care of all the coefficients. We're doing these two. Oh, we didn't write this explicitly, but I think it's clear. So KY is a dagger, B dagger minus AB. And KZ, we said, is minus, I pulled out A dagger A plus B dagger B. And one I'm going to not write it. It's just one, right? It commutes. But so it should
Okay.
not look suspicious.
No, let's check.
If you don't
all the-
have one there with the KY and then now you do.
Oh, but no, I think I did no here. Oh, here no, there is H bar here, right? Maybe write this
We
explicitly.
have KY there though.
So let me say, so this is H bar over 2. Is this okay?
Oh, okay.
Right.
Okay, thanks. It's better.
Minus AB.
Oh, okay.
Thanks.
Right.
It's a lot clearer now.
Yeah. And this is this. Yeah, I think I still have space. I just noticed. I was trying to save space
Okay.
that earlier. Yeah.
So let's count all the minuses, i's, and so on. Looks okay.
Right.
Minus from this, another from this.
Yeah, minus is this one.
Yeah.
And H bar over 2i, H bar over 2, and then 1 over H bar.
Okay.
So this is my I square is -1 H bar over 4. And I think, is that an immediate cancellation? It's probably that 4. Right. But I was just bluntly doing it. um, 4 and 3. Where I took a, shall I write it down?
Yeah, write everything.
Yeah,
Unless something is obviously 0.
The next one is 0 because B commutes. Right?
Mhm.
Okay.
I mean, I don't mind writing. Plus. This goes to 0. Oh, we earlier made a mistake, I guess. I think I was saying this is 0. This is 0.
Mhm. That was 0. The fourth term is 0.
Fourth is 0.
Fifth term is 0.
Fifth is 0.
And the eighth term is 0.
Okay. And here A dagger and A dagger go to 0. So it is A dagger has to come out, right? So minus A dagger. A dagger, this one. And minus A dagger. E dagger for this.
and then plus AB,
Minus, right?
minus AB,
Minus AB.
and then
Yeah. Minus.
minus AB.
Bad.
So we pull the minus sign out, we get H minus H bar over 2. Yeah. Yeah. A dagger, B dagger, plus AB.
Which is what can, no, minus, right? Which is minus KX. Okay.
Yeah.
Right. So we said if this is KZ now. Yeah, I think two of them should be minus and then it's SO21. So this is KX and this is minus. KX, I guess that's what we did, yeah.
Minus KX.
And so the other one would be minus KY.
Hopefully, yeah, that's all we have to do, and then we and I think this, if it is minus KY, then this is SO21.
It is still to 1, yeah.
And then we have to do this, of course. Yeah, this is what really reveals the SO21 structure of the lines. Then, but yeah, good, right? Questions? Yeah, okay. So, yeah,
This is pretty cool.
yeah. As from Urich's diagram, so I was writing to Urich in the morning that diagrams. So I think pedagogy. Usually you say, "Oh, diagrams are pedagogy." That's not so much. It's not pedagogy anymore.
Actually, once I do this diagram, I thought we should really calculate all of them, but I didn't think there would be something really interesting. But you got it.
Yeah. So,
What is the significance of the SO21 algebra?
Lawrence.
And so,
So yeah, Lawrence.
Yeah, I mean, it's sort of, but for me, it is different in the sense. In hydrogen atom, the same structure shows up when you're doing it. And I was telling you that we call it accidental degeneracy, so the idea is to release it.
yeah, they will be corresponding to this so-called split quaternions. I have yet another diagram, which I think might be somehow corresponding. So this is for SU2, this is for for SL to R. SL to R. SL to R, the group
SO2 is connected
with this.
yeah, SO2. Yeah. Yeah, okay. Okay, so let's see. So I think
This
I don't
looks
mind.
looking good.
So before we celebrate, let's
Hmm.
Z is minus, so it is minus on the right. We also
We're gonna have 1 minus or 2 minuses. So you have.
so
Yeah, so 2 minus is 1 plus,
it's
or
the same.
it doesn't matter because you change the basis into minus and you
Yeah.
get the other one.
So it's gotta work.
Yes.
so it has to work. So
Yeah,
Yeah,
because
because
2 minus
do
is
it
1
and-
plus is equivalent to 2 pluses and 1 minus by the change of the basis into minus.
minus.
But go ahead and do it.
Yeah, let's be happy,
We'd
yeah.
like to know.
We want to know, what happens here.
A dagger,
And then-
this is KZ, KX.
And then A dagger, B dagger, plus AB.
Minus H power 1 over Y.
4I.
4.
Hmm.
Right power, how much is that's what we done. Take out A dagger. Out. And B dagger survives. I think I should just do it explicitly the way I.
Yeah.
And we don't think of.
Steady. Yeah.
Right? Any immediate things going away? Nothing else.
Why has an eye in fire?
So nothing goes away immediately.
That was, yeah, we missed before. Yeah, why doesn't? We're good.
You're good, we're good.
So here in dagger, A dagger is 1.
We pull up.
So that's 3 dagger. Dagger.
Okay,
Plus.
that's 0.
Yeah.
That's 0. So yeah, so that's 0. I'm right.
So then the next one is 0 as well.
Plus minus. Minus AB. This one's BB dagger, so plus this 0. It's minus
Minus AB.
I think that's
Oh,
what
yeah.
we're-
Minus H bar of 2. A dagger B.
Minus up in front. Here, the
Just the one line, third
You didn't
line
care
up
about
from the
it.
second line.
minus.
Oh, there's a minus. Yeah, that's necessary, I suppose, because minus
Why?
AY. Right.
Two minus the.
Yeah.
Okay.
Nice, yeah. Yeah, I didn't reach until there. So
Wow, that is.
now we can try this.
This, I think so. Yes, this is 90 pages.
Huh?
I said this is going to take up a lot of space in my thesis. That's a poet.
Well, that's every journal when you submit, they have limitations. Thesis is one place that is no limitation.
Yeah.
You can make it 1,000
Last time in
pages.
your life.
Yeah.
Only opportunity you get. Then people say, oh, this is not right, that's not right.
Mhm.
Now it's only me probably who is going
Is
to
that
come in.
checking from?
Mhm.
And once you have that, then you have to.
Yeah, so
Somehow you
this
figure
is,
that out.
yeah, so this was a remark to all that stuff. Yeah, it is.
Yeah, these are the matrices. Yeah, if you write them with as matrices, you can do all the
Yes,
calculations.
so maybe I'll send you this paper of mine and then start on page 18.
Or convert you to crop to.
Yes, I'll send it to you too, and
Yeah.
whoever wants it.
Do all of that, I think you can do all of angular momentum theory using crop to.
Yeah.
But
You have seen SO21 for sure, right? Yeah. So
Behind the corners, over there. All over the place.
this is a J plus. I thought X was an X. X is just J plus.
X is J
What we
plus.
call X.
Ah,
Program.
I
It's
see,
just
I see.
There's no, I thought there was an extra parameter, but there's no.
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 That's nice. So you know, on the,
stop the recording. You want the recording going or
no.
are we done? Right?
On the Lie algebra level, if you complexify these algebras, probably complexify, they have the same Lie algebra as L2